hundreds of millions of years ago, long before dinosaurs became famous and long before mammals learned ambition. Vast oceans teemed with microscopic algae and plankton. Using photosynthesis, they quietly captured solar energy and turned it into organic matter. When these organisms died, many sank to the seafloor, settling into oxygen-poor mud where decay slowed to a crawl. Instead of rotting away completely, their remains piled up layer by layer, season after season, century after century. Rivers added sediments, seas advanced and retreated. Time did the rest. On land, early plants joined the story. Swamps and wetlands filled with dense vegetation that collapsed into thick mats of organic debris. When floods buried these layers under sand and silt, they were sealed off from air, locked away like forgotten meals in a geological refrigerator. This wasn't rare or dramatic, it was boring, repetitive, and astonishingly effective. Earth repeated the process over millions of years, slowly banking carbon-rich material beneath growing layers of rock. The crucial detail is that nothing here involved oil yet. There were no black pools, no sticky residue, no smell of fuel. Just buried life compressed by history. The planet was quietly preparing a substance humans would later treat as if it had been waiting, just for them, even though it had no such intention at all. Buried organic matter does not become oil simply by waiting politely, although it does wait impressively. What turns ancient plant and plankton remains into something flammable is a slow, relentless partnership between pressure, heat, and time, three forces that never hurry and never forget. As layers of sediment continued to stack up, the weight above increased, squeezing the soft, carbon-rich material below. Temperatures rose gradually as burial depths increased, not dramatically, but just enough to encourage chemical rearrangement rather than destruction. Somewhere between roughly 60 and 120 degrees Celsius, what geologists casually call the oil window, the real transformation began. Under these conditions, complex organic molecules broke down and reassembled into hydrocarbons. This was not a single reaction, but a long chain of small changes, each one nudged along by heat and pressure. Over millions of years, thick kerogen, the intermediate waxy substance formed from buried life, slowly cracked into liquid oil and natural gas. The planet was in effect cooking without a recipe and without supervision. Oil, however, is restless. Being lighter than surrounding water and rock, it began migrating upward through tiny pores and fractures in the Earth's crust. Most of it never made it far, becoming trapped in porous rocks capped by denser layers that acted like lids. These became oil reservoirs, hidden and silent, waiting for nothing in particular. Some oil continued rising until it reached the surface, seeping out slowly, in places where geology allowed escape. Long before drilling rigs and pipelines, the Earth was already leaking. This explains an odd but important detail. Oil is not evenly distributed. It appears in certain regions, not because those places were special, but because the conditions lined up just right. Organic abundance, deep burial, the correct temperature range, and a geological structure capable of trapping fluids. Miss any one step, and the experiment failed. Most buried life never became oil at all, which makes the stuff less inevitable than it feels when seen at a gas station. Before oil-powered engines or inspired arguments, it simply appeared unexpected, inconvenient, and occasionally useful. In some regions, oil reached the surface naturally oozing out of the ground in thick dark patches that smelled strange and behaved badly. To early humans, this substance was neither fuel nor treasure. It was just another odd feature of the landscape like salt crusts or bubbling springs, except far messier. Cavemen did not discover oil so much as stumble into it, and immediately wish it were less sticky. Humans encountered natural oil seeps thousands of years ago, particularly in areas like Mesopotamia, the Caucasus, and parts of North America. The substance was often called bitumen or pitch, and its most obvious quality was its stubborn refusal to wash off. This turned out to be surprisingly useful. Early people used it to waterproof baskets, boats, and buildings, noticing that water stayed out. When black goo was involved, leaky roof, add pitch. Cracked boat, more pitch. The solution was always the same and rarely elegant. Oil also found its way into tools and rituals. It was used as an adhesive to fix stone blades onto wooden handles, making hunting tools more reliable. In some cultures, bitumen appeared in burial practices, construction, and even medicine, applied with confidence that exceeded scientific understanding. This was not ignorance so much as experimentation. Humans saw a material that resisted decay and decided it must be helpful. Which, to be fair, it often was. What matters is that oil remained passive in this relationship. It did not change society or accelerate progress. It was useful, but not transformative. No one reorganized their life around it. Cavemen did not fight wars over it, nor did it shape empires. Oil existed as a regional curiosity, respected, slightly feared, and mostly ignored. Its future importance remained buried just as deeply as most of it still was. At some point, oil stopped being a curiosity and began behaving like a multiplier. This shift did not happen quickly, and it certainly did not happen when humans first met the stuff. For centuries, oil remained a supporting character, lighting lamps, sealing walls, making things unpleasantly sticky. The real change arrived when humans learned how to refine it, and more importantly, how to use it to release energy on demand. In the 19th century, as industrial societies grew impatient with muscle wind, and water oil quietly stepped forward. The invention of the internal combustion engine transformed oil from a material into a system. Suddenly, ancient sunlight could be ignited in a controlled space, producing motion rather than smoke. This altered transportation, manufacturing, and warfare almost simultaneously. Trains, cars, ships, and eventually aircraft relied on refined petroleum compressing distances and rearranging economies. What had taken weeks now took days. What had required many workers now required a machine and a fuel supply. The consequences were not subtle. Oil reshaped geopolitics, drawing invisible lines across maps and making certain regions strategically vital. Entire industries rose around extraction, refinement, and distribution. Cities expanded. Pollution followed. So did unprecedented mobility and economic growth. None of this was planned by the plankton that started the process, nor by the cavemen who once used oil to patch a canoe. Seen from a long view, oil is less a villain or hero and more a reminder of scale. It represents millions of years of stored energy released in a few generations. Humans did not create oil, but they did choose how fast to burn through it. The irony is difficult to miss. A substance formed by extreme patience now defines an era known for urgency. Oil began as buried sunlight and ended up illuminating, accelerating, and complicating nearly everything humans built on top of it.